Hey everyone, and welcome. Think about it. Every single day, you type names like google.com or wikipedia.org into your browser, and boom, the right page just shows up. But how? How does that actually work? Well, today, we're going to pull back the curtain on one of the internet's most important but totally invisible systems, the Domain Name System, or DNS. I mean, it's a fair question, right? The internet is this gigantic global network with billions of devices connected to it. When you ask for one specific website, how on earth does your computer know exactly where to go to find it? It's definitely not just guessing. Turns out, there's this really brilliant system working behind the scenes. So, here's the core of the problem. We humans, we're great with names. Wikipedia.org, easy to remember. But computers? Oh, they don't care about names. They speak a totally different language, the language of numbers. Specifically, IP addresses, like this long string of digits you see here. There's a major translation gap.
And that is exactly where DNS comes in. You can think of it as the internet's universal phone book. It takes the friendly name we give it and looks up the not-so-friendly numerical address that the computer actually needs to connect. Without DNS, we'd all have to memorize those long IP addresses for every single site we visit. Can you even imagine? What a nightmare!
Okay, so how does this giant global phone book stay organized? I mean, it can't just be one massive chaotic list. And it's not. The entire system is structured like a giant upside-down tree. It's this beautiful hidden hierarchy that brings order to the whole shebang. And this analogy is just perfect. The idea of a tree of names is something you can probably get your head around pretty easily because it's almost exactly like the file system on your computer. You know, you have drives, then folders, then subfolders, then files. Every web address has a logical place in this structure, just on a much, much bigger scale. And it all starts from one single universal point, the root, which is kind of funny because it's actually represented by that final dot you sometimes see in a web address. From the root, it branches out into the big categories, the top-level domains, or TLDs. You know these as .com, .org, or country codes like .es. Then you get the second-level domains, the unique names people register, like Google or Wikipedia. And from there, you can get even more specific with subdomains and individual computers, or hosts. So here's the really crucial part. Because of this tree structure, every single address on the internet has a unique, unmistakable path right back to the root. There are no two paths that are the same. That's why there can only be one google.com. This whole system prevents total chaos and makes sure that when you ask for a website, you get the right one every single time. So just how big can this tree get? I mean, how deep can the branches go? Well, the people who designed this system were really thinking ahead. Theoretically, the DNS structure allows for a depth of up to 127 levels. That is a truly staggering amount of complexity, just this nearly bottomless potential for organization. But what do we actually use? In the real world, about 3 to 5 levels deep. That's it. Most of the domain names you'll ever type are that simple. And that's kind of the beauty of it, right? It's a system with almost infinite potential, but it stays simple and totally manageable in practice. It's just elegant. Okay, so now that you get this whole tree structure, you've basically unlocked a new skill. You can now read a web address not just as a random string of text, but as a precise map, a set of directions for navigating that tree. Now, the official technical term for a full, unambiguous address is a fully qualified domain name, or FQDN. Sounds a bit nerdy, I know, but the key thing to know about a true FQDN is that it always includes that final dot at the end, which explicitly points to the root of the whole tree. Most of the time, our browsers hide that dot and just add it for us, but trust me, it's always there. All right, take a look at this fully qualified domain name. At first glance, pc22.asix.es.com might look a little complicated, maybe even intimidating, but it's not random at all. It's a precise address. And the secret to reading it is simple. You start from the right and move left. Let's decode this thing together. We start all the way at the end with the dot. That's the root of the entire internet. Moving left, we hit .com. That's our top-level domain. Next up is .es, a specific second-level domain. Then we find .asix, which is a subdomain inside of es.com. And finally, we arrive at PC22, the specific computer, the host machine. See? It's a perfect path from the most general point, the root, all the way down to the most specific point, one single machine.
So this whole thing is incredibly organized, which leads to a really big question. Who's in charge? Is there some single company or one giant server somewhere running the entire internet? The answer, thankfully, is no. And the solution they came up with is just as clever as the tree itself. The key concept here is that DNS is a distributed system. There isn't one giant phone book stored in one place. Instead, the responsibility is delegated and shared across thousands upon thousands of servers all over the world. Each server only needs to know about its own little part of the tree and who'd ask if it gets a query for a part it doesn't know about. This table really shows how that delegation works. At the very top, an organization called ICANN manages the root zone, basically deciding which top-level domains are allowed to exist. Then, for a country-specific TLD like .es for Spain, a designated organization like red.es gets the authority to manage it. They, in turn, handle all the domains registered under .es. And when a company like Google comes along and registers google.com, they become the manager of their own piece of the internet's namespace. And this is where it gets really powerful if you own a domain. Once you have something like google.com, you can create as many subdomains as you want. Think mail.google.com, docs.google.com, whatever. You don't need to ask for permission or register them with any outside authority. You are the boss of your own branch of the tree. It gives you complete autonomy. So, the next time you type a web address into your browser, just take a second to remember the invisible map you're using, that elegant, upside-down tree that brings order to the entire digital world. It kind of makes you wonder, right? If the internet is a massive library and DNS is its card catalog, what other incredible, invisible systems are we all using every single day without even realizing it? Thanks so much for tuning in.